Hello and welcome, everybody. My name is Steve Teresi. I'm the Director of Training and Technical Services here at JL Audio. I am located in Southern Florida, hence my warm weather, here at the main headquarters for JL Audio. I'm joined today by Kevin, who's up in the Pittsburgh area. Please say hello, Kevin.
What's happening, everybody?
And over on the West Coast is Mr. Rob Haynes, and he's joining from Southern California. Please say hello, Rob.
Hey, everyone. Thanks for joining us today.
Excellent. Well, Kevin is the man of the hour tonight. We're going to get into a conversation regarding active versus passive crossovers. Don't jump to the end. This is an interesting topic that we've talked about a couple of times in the past, but we got a few extra wrinkles this time today that Kevin's going to drop on us. So before you do anything, everyone joining us on Facebook, there are no other links in the chat right now. If you see anything that says click here to watch the training, you're already watching the training. So there's no need to click on anything. Please ignore all of those. We're doing our best to squash those as they come up. You will at some point possibly see a message from Rob or myself in the chat that guides you towards typically our Help Center articles. So if something comes up in our conversation, you'll see that coming properly from JL Audio team members like Rob or myself. Kevin, on the other hand, will not be able to see a lot of these comments because he'll be presenting for us. And I'm going to stop talking now and let Kevin go ahead and take over, and we'll have some fun.
All righty. I appreciate it, Steve. All righty, you got the right thing up there. Thanks, Rob. All right, so like Steve said, this today's conversation, and it really is kind of a conversation and discussion. We're going to go through a bunch of different stuff on active and passive filters. And why are filters so important? Well, no single speaker or driver can really cover the full spectrum of the audio signal properly. If we want to reproduce it all, we need to use different drivers and have them work together to cover that entire range. The proper use of high-pass, low-pass filters can give us excellent results when they are done properly. In this session, we're going to go over and cover many of the distinctions on what we mean by proper use, done properly, excellent results, and we're going to really focus on the two main mechanisms, and that being active and passive networks. So we're going to start off with some prerequisite content. Some of this content you're probably already going to know, but a quick refresher isn't going to hurt. And if you don't know it, then feel free to ask some questions if we kind of breeze through some of this a little bit quickly. And Rob and Steve can get on that, or we can bring it up to the general conversation in there too. So feel free to ask any of those questions. After that, we're going to get into kind of what active and passive networks are, their pros and cons, tuning differences, and then finish up with any questions at the end there. So getting into our prerequisite content and stuff that you may already know, we're going to go through some of the basics of sound, frequency, octaves, 3 dB roll, mainly stuff that's going to pertain to filters and how they interact and kind of get a better understanding of what they're actually doing. Then we're going to get into filters themselves, a high pass and low pass. And then finally, what are active and passive crossover networks there. So starting off, what is a crossover? Let's get into a little bit of that here. And well, technically speaking, a crossover is the point where a high pass filter or two filters, high pass filter and a low pass filter, cross over one another. So like you have an 80 hertz high pass filter and an 80 hertz low pass filter, they will cross over one another. The filters themselves that are used to get rid of any of these unwanted frequencies allow certain frequencies to pass, and that's something that we usually call a pass band. And those frequencies that are passing through that speaker, just keep that in mind. When you hear us say pass band, that is what we are referring to on there.
Hey, Kev?
Yep.
Just a minor point. I can't think of any frequencies that I don't want. I think what we mean to say about unwanted frequencies is something that's inappropriate for the driver that we're connected to. So low frequencies, we don't really want them on a tweeter. High frequencies, we don't really want them on a woofer. So what we talk about with filtering unwanted frequencies, it's for the specific driver. And as Kevin mentioned, when we have a high pass and a low pass, at some point they will cross over each other and blend together to give us the performance that we're looking for. Tweeters shouldn't do bass, woofers shouldn't do high frequencies. We get rid of those frequencies and we let them work together and only play the frequencies that they're really good at. I, however, want all of the frequencies, so I want to make sure they all work well together.
Yeah, and what Steve's kind of getting at here is where one driver starts to get out of its effective range, the next driver can pick up for it. So for instance, if we have a tweeter tweeter really can't play 200 hertz well, at least not for very long. It might play it once. So we have a dedicated mid-bass driver to pick up and play those frequencies. We are going to get all of them. We just want to make sure that each speaker is playing in its effective range. Now, if they overlap, say we had them playing full range, you're gonna get a listening experience that's not going to be very good. You're going to get a lot of muddledness between speakers, and it's not going to be very reliable on there either. So that's why we use those filters, so that way those speakers are just playing the frequencies that we want them to do, and then they can all sum together as a whole to play the entire range of frequencies in our listening range. So and the networks or mechanisms that we go and we use these, just think about that. They should be inaudible to the program material on there too. They shouldn't really affect how we're hearing those frequencies through those drivers either. So just keep in mind that that mechanism should be inaudible. So let's jump into some of the terms that are commonly used when we go and talk about filters. Octaves is a big one. You
Kevin,
hear that.
Hold on, real quick. The crossover should be inaudible. The effect of the crossover should be very audible. So in other words, when you're listening to a system, you shouldn't say, I think that crossover sounds funny. You might want to say, I don't think the crossover is set right. Or maybe this is the wrong crossover because of the performance that I'm getting. But when we say inaudible, it should not contribute significantly to anything you're actually hearing. It should only make things blend better together. And that's what we mean by inaudible. You shouldn't be listening to the crossover. You should be listening to the effect that the crossover has on the system's performance.
Right. So moving into some of the terms that we're using here, you'll normally hear the words dB per octave associated with high pass and low pass filters. So let's take a look and see kind of what an octave is here. An octave is the doubling or halving of a given frequency. It doesn't really matter what the number is. It's just the doubling or halving of that. So you can see up here on the chart, we have 20 hertz to 40 hertz. That is one octave. We've doubled that 20 hertz. 40 to 80, 80 to 160, 320 to 640. Now you could take 500 to 250. That is also considered an octave, even though it's not on the screen. It's a halving of your given frequencies. So when you hear that utilized, when we're talking about 24 dB per octave, we're talking about that halving or doubling of a given frequency range. Now, another term that you really hear about is decibels. And decibels is a relative term, and that can be used with many different things. My light bulb can have a certain amount of decibels that it's putting off on there and can be measured in that way. So when we talk about decibels, we actually talk about dB/SPL, and that's the measurement of sound relative to absolute silence. And most of the time we talk about this in relationship to getting more performance. But to understand how filters work, we're going to actually look at it a little bit different direction here. So we're going to take a look at our main ones here. So if we double the power, we get plus 3 dB, or if we have the power, we get minus 3 dB. So for instance, 100 watts, we take it down to 50 watts, we have 3 dB down or negative 3 dB from where we were at there. And 4 times the power gives us our plus 6 dB, or a quarter of the power gets us our negative 6 dB. And then 10 times the power, or 1/10 of the power, gets our plus 10 dB or minus 10 dB on there. And I'm just giving you guys these formats because these are ones that you see us use quite often when we talk about gaining and getting more output out of a system itself. Now, I want to step in and talk about ones that are really directly related to our high pass and low pass filters. And we're going to start off with 6 dB. So 6 dB is quarter of the power, like we talked about earlier there. Now, another one that we commonly hear about with filters is 12 dB. And 12 dB would be 1/16 of the power. So 12 dB down would be 1/16 of the power itself. Now, the big one is negative 24 dB. To get negative 24 dB, like we would hear on a slope of 24 dB Linkwitz-Riley filter, that would be 1/256th of the power that it takes to go across there. So just keep out on that and think about that. So Let's start off with taking a look at the filters on here. We have amplitude on the left going up and down or vertically. We have frequency at the bottom going left and right on there. And what we have is a red line that designates a full range equal output response on there. So we could see that red line. And we're going to actually walk through and show you a couple different filters and what they look like as an electrical response. And we're doing this as an electrical response because it's a clear representation. There's no acoustical anomalies that are happening in there, reflections or anything like that. And we will be able to show you those appropriately.
Oh, that's a fancy way of saying that the lines are easier to look at.
Right. So we're going to start off with showing a 12 dB per octave Linkwitz-Rayleigh filter. With Linkwitz-Rayleigh filters, the cut point is always at 6 dB down. So if we choose 80 hertz, at 80 hertz, it's always going to be 6 dB down when we're using that Linkwitz-Rayleigh filter. So depending on the slope steepness will affect where that reduction starts and how steeply it rolls off after that 6 dB down there. Other filter types are available. They'll represent themselves a little bit differently or present themselves a little bit differently. But for what we're doing here and just showing you the differences on the slopes and all of that good stuff, we're going to stick with the Linkwitz-Rayleigh filters and show you guys some comparisons here. So going through our second one here is 80 hertz at 24 dB per octave Linkwitz-Rayleigh. Now, this one is one that we utilize pretty common as a group. If you don't have the ability to go in and take acoustical measurements, which I hope you can always go in and take acoustical measurements, this is a great starting point for you, whether you can or can't actually. Because what happens is when you take a look at the way they interact with one another, a 24 dB Linkwitz-Rayleigh high pass filter and low pass filter, they can actually sum flat. And I'll actually show you that here in a few seconds as we get down there. So this one's a real popular one that we can use. What's that?
That assumes that they're at the same level. So if your mid-range and your tweeter are at the same level and you have a high pass and low pass at 5,000, the equal level electrically will sum flat. Acoustic things, kind of all bets are off a little bit.
Right.
Same kind of principles apply, but again, making the lines look pretty for the concept of what high pass and low pass filters do, this is an excellent representation.
Yeah, and this is, like we said, it's a real common one that we use here. And you can notice it, and we'll show them all together, but if you remembered what the previous one looked like, this one starts a little bit lower in the frequency range and tapers off a lot sharper than what that 6 dB or 12 dB one did earlier. Now, putting a 48 dB per octave high pass filter on here. Sometimes we refer to this one as the brick wall filter because it's extremely steep on there. And we can see that roll off. The roll off is a lot more pronounced on there. The taper starts a lot later and then comes down very steep on there. So looking at them all together, you can take a look and see how they kind of work and how they roll off. The less the slope on there, so like a 12 dB slope, it starts a little bit earlier and rolls off a lot more gradual, where that steeper 48 dB starts a little bit at a lower frequency and then cuts off very sharply. And that's again,
sorry, that's a really good image because all of the filter frequencies, you can see they all overlap. They're all meeting at that same 80 hertz, and that's why the high pass frequency in this case is a given value. But if you simply said, I crossed my tweeters over or I crossed my mid bass over at 80 hertz, it doesn't really tell us a whole lot. We need to know that the rate of that attenuation. And looking at this chart right here is really helpful. Between those three different colors, you can see the more aggressive filtering versus the less aggressive filtering. And it also kind of speaks into why Kevin was saying that a lot of us will go right for a 24 dB per octave because it's a nice happy medium for the two more extreme things, one that's a little too gentle, one that maybe is a little bit too steep. But it's nice to have options, and it's a good thing to be able to change that. It would be nice.
It is. And like Steve said, I feel like you're setting me up for something here, but I'm not sure what that softball came from. And like Steve said, you'll notice that they all intersect at 80 hertz there, and it is at 6 dB down. Now, if we were using something different, like a Butterworth filter, they would actually all intersect at 3 dB down, and that's one of the main differences between those on there. So just keep that in mind. And again, we're only looking at the electrical response here. Measured acoustical responses will differ, and you could have a slight difference, or you could have a really subtle deviation from these responses too. So just keep that in mind. Again, we're just looking at electrical. Now, here's what Steve was saying earlier when we were talking about how the 80 hertz high pass Linkwitz-Riley and an 80 hertz low pass Linkwitz-Riley at equal amplitude will actually sum flat. So we have our high pass and our low pass, and then the yellow line across the top is our sum of those two filters. And you can see that that sum is completely flat because they are on that, that same amplitude of one another. So this example is a good example of a two-way component set. So you have a tweeter, a mid-bass or a mid-range driver, and then a subwoofer on there. The sub is low passed at 80 hertz. The mid is high passed at 80 hertz, and then low passed at 50 hertz or 5 kilohertz. And that creates what we call a bandpass. So when somebody talks about filters and a bandpass filter, it gives a certain band of frequencies to be able to pass through that speaker there.
It's a technical term, though, huh?
Right. So that is when you hear us referencing bandpass, that is what we're talking about. And then we have a high pass on the tweeter there at that same 5 kilohertz frequency on there. So passband, like we said, that's another term that we use often. And just to give you a quick refresher on there, that is the range of frequencies that is passing through that specific speaker. So for this instance, the mid on this, the passband would be 80 hertz to 5K. Those are the frequencies that we're sending through there, the majority wise. So this is an example of a three-way system. Crossover points here are at 80, 500, and 5K, depending on which speaker you're looking at, and the high pass and low pass on there. But you kind of get the gist of things. And again, we're using 24 dB Linkwitz-Riley. We're all at the equal amplitude there, as you can see on the left-hand side. So you can see that yellow sum is completely flat across the board. Now, listening to this, that flat sum, we wouldn't really want that. We want to be able to hear a little bit more down on the low end and maybe taper off a little bit on the upper end. But just showing you guys how these filters interact with one another and how they will equal out, and why this is such a good starting point with those 24 dB Linkwitz-Riley filters. So why do we use filters? Well, it's a question that we're going to go through and walk through you guys with this again. Again, amplitude is on the left going vertically on this chart. Frequency is at the bottom going horizontally. And we want to talk about why we use filters and how they interact with the speakers themselves. And we're going to show you the equal loudness and equal energy across the board here. So this line up top is just showing an equal loudness or an equal frequency response at the same amplitude all the way across the listening range there. Now, we want to look at what is needed if we're going to make some changes here, specifically with excursion. In excursion, if we have a certain amount of excursion at 100 hertz, let's say it takes a 1/4 inch of excursion at 100 hertz to keep this amplitude up. Okay, so we're at 1/4 inch of excursion at 100 hertz for that amplitude. If we go down 1 octave to 50 hertz, it actually takes 4 times the amount of excursion to keep that same equal energy as it did at 100 hertz there. So that 1/4 inch of excursion now turns into needing 1 inch of excursion to maintain that equal energy and that equal loudness through there. Now, if we take it one more step down, at 25 hertz, so we go down 1 more octave from 50 hertz down to 25 hertz, we now need 16 times the amount of excursion, or now we need 4 inches of excursion from that same exact driver just to maintain equal loudness across the board there. So when we take a look at that here, we have that 16 times at 25 hertz, and we have that 4 inches of excursion is what is needed in there. So at 25 or at 100 hertz, we have a 1/4 inch of excursion. At 50 hertz, we need 1 inch to maintain. And then at 25 hertz, we need 4 inches to maintain across the board there, that equal loudness and equal energy. And I'm not sure how many speakers that are out there that are very efficient at 100 hertz that are also very efficient with 4 inches of excursion at 25 hertz on there too. I see Steve's making a face there.
That's
I think he's in agreement with me on that one. So what we want to do is we want to use, what's that?
No, it's a lot of the curves you showed earlier about high pass and low pass filters. What effectively happens with a subwoofer or any driver that has a limitation as it gets lower in frequency, it becomes almost like a mechanical filter that it can no longer produce out, which is why when you look at it like enclosure design software, you'll look at the low end response and invariably it will taper off like a high pass filter. So, and that's because the mechanics of the speaker prevent it from playing those lower frequencies. So it's kind of an interesting, although weird way of looking at it. We have electrical filters and here's a mechanical filter in practice.
So let's take a look at why we're going to go ahead and get in here and put a high pass filter on this. We're going to put a high pass filter on this speaker at 80 hertz. And so that way we're not trying to reach those mechanical limitations that Steve is talking about. I'm sure probably all of us at some point in time have heard a mid-bass driver bottom out at some point in time. And I see Rob and Steve are shaking their heads there. I'm sure a couple people listening on there. Glenn,
you never play it that loud, Kevin. Come on.
Somebody has heard a mid-bass driver reach its mechanical limits or a mid-range driver reach its mechanical limits on there. So we want to use a high pass filter on there. That way we're not making that speaker try to play frequencies it wasn't designed for. And it's going to make the system a whole lot more efficient and a whole lot more reliable on there. So we can see this 80 hertz high pass filter at 6 dB down is at 80 hertz. So we know that is a 24 dB Linkwitz Riley that we used on there. And just some references on there at 3 dB down, you are at half power. And that's kind of how that filter is cutting back power going to the speaker, reducing the excursion, reducing the stress of the driver. And then your subwoofer will come in at that same range and be able to pick up those lower frequencies for you. And everything is going to work well with one another, especially if you have the flexibility to adjust these filters in different ways. So now that we kind of know how filters work, what they're doing, and all of that good stuff, let's get into the active and passive conversation and get into some of the details here as we go through some of this stuff. Probably going to slow down a little bit and have more of a conversation as we go through some of these things. And I'm sure there's going to be, or I hope there's going to be some good questions that pop up as we're walking down through some of these things also. So when we talk about passive crossovers, caps and coils create fixed filter points on there. I know we have a picture up there. I've got a C3 one actually here with me that you guys can take a look at. So caps and coils are on there. They create fixed filter points, and they usually are a two-way crossover to where they create a filter point for the tweeter and a filter point for the mid-bass or mid-range driver, depending on what's going on there. So you have your high pass and a low pass for your mid there. Usually the tweeter has some sort of level adjustments. This specific one here has reference level, -2 dB, +2 dB, and -4 dB on there. They may vary depending on which brand or which line you're looking at or anything like that. But normally they do have some sort of tweeter level, especially when you jump up into an external and get out of just an inline filter that's on some of the less expensive pieces there too. So some of them also have mid-level adjustments when you get really high end pieces. This one has a mid-range presence on there where we have a high and a low. We can change the presence of the mid-range on there. Some of them allow for separate inputs for mid-range and tweeter, which is called bi-amping. If you ever hear that terminology, that's what they're talking about, bi-amping a passive crossover network. You'd have 4 sets passive inputs on here. So you'd have positive and negative for mid, and then positive and negative for your tweeter on there too. So that's what biamping is on here. I'm actually showing a ZR passive network on here, mainly because it had the best photos out of all the ones that were available to go ahead and grab on there. But they also do have a lot of features that are available on those networks too. And then, like I said, I have my my C3 one that is sitting here.
A couple of interesting things about passive networks in general. When they're designed, what the type that we're showing here are designed to go between your amplifier and your speakers, your tweeters, your mid-range, or whatever the case may be. You could technically do it before the amplifier with passes, but that's goofy. No one does that. So we'll get into active filters separately, which are slightly different. But when it comes to these products here, there's an assumption that has to be made during the development of these crossovers. We have to assume where each driver is relative to each other. So while as an engineering company, we do our best to try to approximate how far away a tweeter might be so that when the crossover works together, and again, Kevin mentioned earlier, one of the criteria is that you don't hear the crossover, you hear the result of the crossover. And because the drivers are not in one point in space, we have to anticipate how far apart they may be. And one question that often comes up is how far apart should the tweeter be from the mid-range? Well, that really is going to be more of a car question than it is from a design point of view. We have to make an assumption, and very often that assumption may not be exactly what you guys are doing, which, in my opinion, I know I'm jumping ahead, Kevin, to the con of a car. But that's something to keep in mind, that there is some assumptions that have to be made. I haven't taken all of it away from Kevin. There's some other assumptions that are also made, but I'll let him work on that. Sorry.
That's all right. So let's talk about some pros on passive network systems. One is it's a simple setup. You go in, you connect your wires up to it. Normally the parameters are set pretty safe because, again, they're taking some assumptions, like Steve said on there. Excuse me. And they can give very good results. And most of the time when you get these good results, it's in a home setting. So you think about a home cabinet, and a lot of home cabinets use passive networks on there because the cabinet is a given entity. They know what it is. They know the distance between the tweeter and the mid-bass driver. They also give a fair assumption that in a room, you're going to have equal distance between left and right speakers on there too. So you're going to have that equal listening coming at you too. So in a home environment, passive networks actually work fairly well. You don't need as much adjustability in them as you would in a car or a marine environment per se. Oh, I thought Steve was going to say something there.
No, that's right. You mentioned that they can do quite well in a home audio situation, particularly between like a mid-range and a tweeter driver. You can get some decent results with a passive network in those aspects. But as Kevin will get into, I think anyway, as you get lower in frequency, sometimes passes are not the best thing. Sometimes they're not even possible, not in a practical sense anyway. Try finding a passive network for a 80 hertz low pass filter for anything. So good luck.
Right. So the setup on them is fairly simple. You set your high pass filter on your amplifier, or if you're not using an amplified output and you're just using deck power, a lot of receivers have some sort of filter networks in them that you can go in and utilize a high pass filter off of that receiver to go in and get you set up. So it is a fairly simple setup. Now, some of the cons that are on there, they are extremely limited by their simplicity. You cannot go in and make adjustments to where those filter frequencies are. So you got to keep that in mind. And having two separate speakers with one input can cause some challenges when you're trying to really get in and try to tune or dial in your system. Where do you set your delay to? Level settings can become very time consuming. Mounting the passive network can also add build to your time there too. If you're running active, you run two sets of speaker wires. You're running one set of speaker wires anyway, so you're already doing all of the work. You're just running another set in there. Now, when you're adding in a passive network, you have this passive crossover that you need to mount. And please do not mount these in the door. I'll just throw that one in there. real quick. So you want to make sure
everybody is doing it. We all laugh. We all shake our head. I'm telling you right now, I'd say 75, 80, or maybe even higher numbers are still dropping those things in the doors. And it drives me nuts because there's some flexibility in there that could really help in terms of tuning the system. And you're basically burying it and saying, all that fun, I don't want any of that. Yeah, I know it's a pain in the neck to run that extra wire into the door. I know it, but it is worth the effort, especially if you got to stick with a passive network. So that's a sort
the
of
thing that doesn't make sense to me is even if you ran those in, if you mounted them in the door, you still got to run wire into the door to the crossover network. So, even the most robust passive network, you still have very fine solder points, lots of connection points that can, rattle loose with the vibrations from the car. And, God forbid you're in Florida, or when I used to live up in Seattle, and you have all of this rain that seeps into your door and starts to rust stuff out if they're exposed. So be smart, keep them where they're safe, and just, you already got to run wire into the door anyways. Just run an extra pair up to the tweeter, and you're good to go.
Now, another thing to add, kind of what Steve was saying there a little bit earlier, is the built-in filters are based off of a fixed value of resistance and not impedance, and just adding on to kind of what he was saying there. And that result is actually nonlinear. As the impedance changes, the behavior of the filter is going to change also. So what you think you're getting may not always be what you're actually getting in the acoustical domain there. So just keep that in mind. And the other thing is this fixed value is often based off of the speaker being free air. So if the speaker's in a kick panel where it's very, very tight, confined area, you're going to get a little bit different variation from it too, rather than it being in a door that may be deadened off and opened up and all of that good stuff too. So just keep in mind, you are going to have some variations depending on how the speaker is installed in the vehicle also.
So real quick on that topic, just to give you guys an insight into how many companies would develop their passive networks. In order to develop it, as Kevin just mentioned, you need to pick a value to start with your filter design. You need to find what resistance value, and drivers don't really focus on resistance. As Kevin mentioned, it's impedance, it's resistance and frequency combined, so to speak, as a simple way of putting that. But you need a starting point. So what will typically happen is we'll pick a 4-ohm tweeter and a 4-ohm mid-range, assuming that's what the DCR, the nominal impedance is. And we'll use 4 ohms to start developing the network. Now, what's funny about this is for many, many years, it was always a struggle for us as JL audio trainers when people say, well, what's the filter frequency on the XYZ crossover? And it's like, honestly, I don't know. And it sounded funny because, well, how do you not know? Don't you pay attention? It's like, because we started with one value. And then as we listened to it and saw the true interactions, we started changing those values to give the performance that we were looking for. It doesn't matter about the filter frequency at that point. It matters about the network working well together. Some of the comments in the chat were referencing Lucio, our lead engineer. And he did a ton of work with passive networks back in the day and continues to play with them. It's a kind of a thing, and he knows enough to know that you can't focus on a single value. You kind of have to start somewhere and vary it based on the overall results that you're looking for. So if we've done well with our passive networks in the past, and I think that we have, but I am biased, it's because we understand that things are different when you actually start listening to it. Everything that Kevin just mentioned is absolutely true. It is a moving target. More power is going to make things different on a passive network. Different tweeter locations compared to the mid-range driver is going to, change the way the passive network works. Putting it in a door versus putting it in a box is going to change the way that the network actually behaves. All of these things make these very non-linear, these passive networks, and that is a detriment. There are other ways that you can get away from all of this that Kevin hasn't gotten to yet. But I just wanted to kind of give some insight as to some of the dynamic nature of what goes on when you're dealing with loudspeakers in an actual car. Things do change. Home, as Kevin already mentioned, you have somewhat of an advantage. In most cases, you know where the listener is going to be relative to the drivers. You also know where the drivers are going to be relative to each other. So you can get away with some of those variables being somewhat finite. You already kind of know what's going on. But when you're dealing with marine and mobile audio, all bets are off. We got things going all over the place in vehicles, and it's very, very difficult to make it right every time with passives. So.
One other thing that Steve and I he actually sent me over an article. I'm not sure where the article was from on there, but it was a really interesting document. And I kind of read through it, and I took one really important excerpt from it. And what that is a 30 watt and 60 watt amplified output running active will clip at about the same level as one 175 watt amplifier with a passive crossover. So keep that in mind and just think about those numbers. You have a 30 watt and a 60 watt amplified output running active that is going to clip at the same level as one 170 watt amplified with a passive crossover network.
That came right from this book here. It's the Loudspeaker Design Cookbook. This was the 6th edition. And there's a section on this version, it's page 152, active crossover networks. And he's kind of making a comparison of what's good or bad about an active network. And he lists 8 goods. I don't see anything else after that. But one thing I want to point out is that this book is kind of old. Let me get the actual print date. The 6th edition. This one was printed in the year 2000.
20 years ago.
The only negative that he actually listed in here was the possible high cost of an active network. Now, 21 years ago, that may have been the case, but these days, active networks are coming built into your amplifier already. In most cases, you don't need something extra to make this happen. Back when he wrote this, the only way to get some of those active filters was to have an external device, an external product. And that is not always the case anymore. So the one thing that he pointed out is not even an issue anymore. So, all right, stepping off soapbox again for a moment.
So let's get into active crossovers and active networks. They've been around for a long time too. Obviously, Steve had a book there from 20 years ago or 21 years ago that was still talking about active networks and how to use them. Just the means and the way we use them has changed a little bit, like Steve was getting to there. Back in the day, I won't say my day, but back in the day, Steve said, you had to use an external filter, external crossover box or an external filter box that went in line there. Now, a lot of stuff is built into receivers, amplifiers, many, many different products out there. So it's a lot more readily available to be able to utilize this type of setup now. And we will utilize some sort of separate electronic crossover, and then we ditch those caps and coils in lieu of that and doing it electronically. Each speaker will be run off its own dedicated amplified channel, and it's usually a direct wire with no crossover between the amplifier and the speaker. Now I'm going to take a second to say most of the time it is done that way. I'm sure there's somebody in the chat that is asking, well, what about C7s? They come with something that goes in line between the amplifier and the speaker itself. Well, that is a cap that protects the tweeter itself, and you guys should use these and always put them in line. It is for protection only. And if you take a look at the mathematics of the cap itself, it's well below the frequency range that you're going to high pass filter the tweeter at. It is strictly there for protecting the tweeter. So make sure that you guys are using that in line. So that's kind of why I say usually it is a direct wire from your amplifier to the speaker, but sometimes you do have the ability to have some sort of tweeter protection that you can go ahead and put in, like the C7s on there. So active crossovers, how to use them. And we've been touching on these here and there and going through. A lot of them are able to do on amplifiers these days. The XD700/5V2, XD1000/5V2, both have the capabilities to run fully active on there. And it's a pretty cool system. I've done it a few times myself where I run a component system and a subwoofer and like a pickup truck. And I run the tweeters off of the channels 1 and 2, and then the mid-range drivers off of channels 3 and 4, and then the subwoofer off there. There is a little switch on the amplifier that will create a bandpass ability on channels 3 and 4, so that way you can go in there and have your mid-range drivers set up properly on there. So it's a very simple, easy way to do it. And like we talked about, some receivers today really allow you to do this too. I was in a vehicle, I don't know what the receiver was, but I was in a vehicle last week, and it actually had a bandpass capability for the outputs, both preamp and amplified output of the receiver, to be able to go ahead and run an active system directly off the receiver itself. Now, one thing I do want to say is if the amplifier does have the ability to do that, I would always go that route. Some receivers, I don't know if they keep that in a non-volatile memory. So if you change the battery out, or if the battery dies, having that on those settings on a non-volatile memory is very, very helpful. That way, when you go and key on, maybe it's been a couple years, you don't remember that you set them up on there. But having that on the amplifier, you key on, you don't have to worry about it. If it's on a receiver, then you have to go in and make sure you go in there and set those settings up right. Maybe take a picture of it with your phone or something like that, just in case it happens, and you have those reference to go back to on there. Now, one thing to mention is DSP, and DSP has become very, very popular these days. And DSP does give us the availability to run an active network, like off of a VXI amplifier or an MVI amplifier at that. Now, it does give us a lot more options on there. But for this general conversation that we're talking about, it does give us the availability to both high pass, low pass, and bandpass on there for your speakers. So DSP really makes this a very easy and available way to go ahead and do it. And it gives us the most fine-tuned way to do it too. You know, when you're looking at an amplifier and you're kind of turning a dial on there and you're looking at your frequency response, well, when you're looking at DSP, you're looking at the exact number that you're changing that to, and the slopes, and have all of those other things that you can go in and change with that too. So it does give you a lot more options when you are going into DSP.
Before you change on that, don't change that, leave it there. So usually when I see the word receiver, I immediately think of home audio. And I know you were talking about the main source signal ahead of the amplifier. So it could be a preamp, like you've mentioned here, or a receiver, and that could be an in-dash receiver, or it could be a home receiver. And a lot of people look at home receivers and they don't really think that there's a crossover, a filter in there. But when you're setting your speaker size to small or medium or large, you're changing that filter frequency by doing that. It is an active network that's going on in there, which is a good thing. And it's a nice way of protecting the floor standards or bookshelves and help them blend with a subwoofer. Most subwoofers will have their own crossover built into them as well. It's not as common in home audio to have an active electronic crossover as a standalone unit. There are certain companies I know that make really good subwoofer crossovers. But know that our mobile audio teams have been using active filtering now for a long time. And a lot of home audio guys have not really seen some of the benefits. They tend to, Kevin alluded to, they'll use a subwoofer that doesn't have a low pass and a main speaker that doesn't have a high pass, and let them blend together. But we know that they'll sum, and they'll usually have a lot of extra energy, and that can make things not so good. So active filtering has kind of been a staple, especially at lower frequencies. And Kevin mentioned earlier some of the nonlinear behavior of passive networks, and that's really where active filters start to shine. You get away from that nonlinearity, which is a really big deal. Just as a point of clarity, again, when I see the term active crossover, that's something that requires power on its own, as opposed to passive that does not require power. In the chat, we were talking about some old devices that used to be pre-amplifier, but no power. They were called F-mods or things like that. That might have been a name brand. I don't even remember. It's been that long. But basically, it was inline on an RCA plug. So you plug your RCA into this and then plug this into the amplifier, and it would filter the signal before the amplifier, but it was not active. It was technically passive, which leads to the DSP thing. And I saw the chat light up, DSP. I think a lot of people expect now, today, that when you say active networks, it's almost assumed that you're using DSP, and there's a really good reason for that. Kevin kind of touched on it. I just wanted to elaborate a little bit on it. If you're dealing with like one of the XD amplifiers or any number of products out there that have built-in analog active crossovers or filters, they have fixed values. You can sometimes adjust the frequency, but the slope, the 12 or 24 dB per octave, it's fixed. You don't have a lot of variability because with each level of variability, there's additional components that are needed. Now, when it comes to frequency, it's usually a variable value that you're adjusting in the analog domain. What gets nasty about those things is over time, some of those parts can get bad, honestly, even some high quality things. And that's why DSP is the way to go. If you have the opportunity to get a DSP in your system, you don't have to worry about degradation over time. You don't have to worry about tolerance drift. You don't have to worry about limitations on what slopes you can use or what frequency. Almost any DSP you're ever likely to use is going to have tons of flexibility and control that you'll never get from another active filter, and you will never, ever, ever see anything even close to it in the passive world. So yes, DSP is the way to go if you can get it into your budget. And I think at this point, many of us can, and I think Kevin's got some things to share, so I'm going to zip it for a moment. Rob's got something to add, though.
I was going to say, Rob's got something to share. I just saw you unmuted.
I was just going to say, as Steve mentioned, like when we compare the benefits of having DSP or a VXI amplifier compared to using the bandpass functionality of the XD, it's not just the adjustment in the filters, but the levels too. You got to remember, a passive crossover network heavily attenuates a very, very efficient tweeter that does not need a lot of power to play very loud. So if you were to go active with an XD series, if you didn't have some sort of independent level control to dial those tweeters in, they're probably going to be significantly hotter than the mid-range. Yeah. So that's the other nice benefit with the DSP is, not only do we have the filter optimizations, but we've got level control as well, where we can make sure everything's properly in balance with one another to make sure we have that smooth result. That really is why we're doing all of this,
So, Kevin, I can't remember what slides are upcoming. I know we have a bit more to chat about, but there's one thing I want to share about the two aspects of crossover benefits. One is performance, which I think we focused an awful lot on that in terms of making things sound good. But the other one is protection. You want to make sure that there's not a lot of damaging things that are going to go to any one of the drivers. When Rob talked about level, it made me think of things that if you don't attenuate things, you're going to wind up overdriving them. I did see something in the chat about someone's using a competitor product in terms of their component speakers, and they're using some, I believe it was one of our amplifiers, and they've been having trouble getting things set right. Well, again, there are lots of things to adjust, and level could be a big part of that, and we want to bring those things in line. That's a performance and a reliability thing, and filters are really critical for both of those. And again, DSP is the king because you can control all of that.
Yeah. If you're dealing with a normal amplifier like an XD, you're dialing back your input sensitivity probably to make some level adjustments on the tweeter or something like that, rather than just utilizing an output level trim that you could do independently for speakers and all of that good stuff like you would on a VXI or an MVI on there. One thing I do want to mention is my good housekeeping for active. Like I mentioned, my good housekeeping for passive networks and not putting them in the door. If you are trying to run an active network, try to keep the filters from one point source. And what I mean by that is don't use a high pass filter on a in-dash receiver and then a low pass filter on the amplifier, and you're going to get mixed up. Things aren't going to mesh well. You might get lucky and they work together, but play the lottery that day for you. So try to use the filters from one device. If you're using like a VXI amplifier, utilize only the filters on the DSP. Keep the receiver just playing full range out of the outputs and don't make any changes from there.
All right, I got to do it here. I got to say it. I really don't like the idea of having filter controls like that in a source unit. Because it's a tuning setting. It's not something that you're going to change on the fly, or it's not something you should change on the fly. If the system's been set up and designed properly and tuned properly, you should never really need to change your filter frequencies. Level control, yeah, I get that. Let's put some level control up in the front, for maybe your tweeters and certainly your subwoofers. But when it comes to filter frequencies, I'm with Kevin, man. Don't even bother using the one that's in the source unit. It may be good, it may not be good, but the one in the amplifier, you can dial it in pretty well, especially if you're dealing with a DSP. Let's use the tools in an area that's probably the safest and smartest. Customers, they like to play with things, and I'm cool with that. Just know that when it's set by a professional shop, how do I put this nicely? They bear some of the responsibility. So if you go in there and start changing some of that stuff, their responsibility goes away, and then it's all back on you. So let them do their job. Let them tune that system, make sure it sounds really, really good, and leave those controls back in an amplifier or in a separate processor in the back of the vehicle. I don't like the control up front. I just don't think it's a good idea.
Yeah, I don't either. And like I said earlier, a lot of times they aren't saved on a non-volatile memory. So if the receiver, if the car goes dead or something like that, then you lose all of those settings. Or if they're on an amplifier, even if it's a DSP amplifier like a VXI or MVI, they have built-in non-volatile memory. Those settings are all going to be saved and stored in there. You don't have to worry about that at all. So makes it nice and easy. Try to utilize what's in the amplifier or what's in your DSP. And like Steve said, leave the receiver flat, not just for high pass and low pass filters, but for most of the settings that are on there too. I know a lot have bass boosts and all of that stuff that can get crazy on you. And we'll save that discussion for another train. So
look, we covered almost all of this in our chat.
Right? So pros, where are we at with pros here? Well,
the list is long, and the cons is a very interesting list. But all kidding aside, you covered all of this. We maximize control and performance. We don't have the losses. The ability to tune is infinitely greater, easier and more precise. It's all great stuff, And right now, simplified install and setup is sort of what we just talked about. Let's simplify everything and keep it in one location, and we can set it all up. Obviously, if you're using a DSP, you can do it all on the computer, or you just do it with the switches on the amplifier. Tuck the amplifier away, sit up front, and listen. Tone controls, I'm okay with up front, but everything else, let's just keep it in the back.
Yeah, exactly. And there's a good reason why our C7, our flagship line of component speakers, were engineered to be used as an active system. At that level, you don't really want anything in there that is in line between the amplifier and the speakers themselves that could possibly diminish the quality or hinder your ability to get the most performance out of that system on there. And like we said, the cap that comes with the C7, strictly there to protect it on there. It's not impeding any of the performance of the driver. So going active really opens things up for your ability to dial them into your system in your specific vehicle. And I want to clarify this. We can kind of talk about this a little bit here and there, but each vehicle can and most likely will present itself differently. The distance between the mid-range driver to the tweeter are often very different. If you take a look at like a 99 Tahoe, the mid-bass driver and the tweeter are a couple inches apart from one another in the door. If you take a look at a 2008, 2010 GMC, the tweeters up in the pillar and the mid-bass driver, mid-range drivers all the way down in the door. So these are going to present themselves quite differently to you. And the way that mid-bass driver, mid-range driver reacts in its environment, it's mounted, it's really going to present itself differently. So having all of the abilities to go in there and make those fine-tune adjustments are really, really important, especially when we take a look at some of these newer vehicles that are utilizing some of these practices already with DSP and getting levels and doing all of this stuff already in their in those systems. So the cons, and let's take a minute and talk about these cons here. There really are none when you're taking a look at an active
Not today,
system.
anyway.
This will be a quick one. This was difficult, and it's difficult for all three of us, actually, because I will say that all three of us are all running active systems in our own personal vehicles because we have the ability to do so. And of all the product that we can go and choose, we chose to run active systems because it is the right way to do it. And there's really not that many cons on there. Really, the only one is that you need more amplified channels to go through there. So a system that we would normally maybe base off of a passive system that would be a 4-channel amplifier, you may need to step to an 8 or a 6-channel amplifier, depending on what speakers that you're using on there. So you need a dedicated amplified channel for each individual driver in the vehicle. If you're using a coax in the back, then it really doesn't matter. You just need one channel for that no matter what. But for your component sets, you need a dedicated channel for each tweeter and a dedicated channel for each mid-bass driver. So you might be able to get away with this going from a 4 to a 6 channel, but you may need to go from a 4 to an 8 channel depending on how the system is designed and laid out on there. And good system design will really help you out in getting this done properly and getting it done correctly on there. And it may require a little bit more expertise, only because, especially if you're using DSP, there's lots of things that you can go in and control on there. Being able to take acoustical measurements are always going to be able to maximize your performance on there. So if you have those tools ready available, then honestly, there's really not any reason to not go active and do that for you. So
100%. So the comment about you might need more expertise because there's lots to control, that means there's lots of things you can make mistakes on. I used to use an analogy, which is very really old now, but with cameras. Back in the day, if you got an SLR camera, you had the ability to adjust aperture and shutter speed and all these different things. And as a result of that flexibility, you could take some really crappy pictures. So when it comes to audio, the equivalent of a bad picture is a poorly tuned system that doesn't perform or possibly causes failures. And Active does invite some of that if you don't really know what's going on. But, Kevin did a really good job kind of recapping some of the terms that we should know before we get into any of these things. And with that little bit of knowledge behind you, you can set up an active filter fairly easily without causing any unnecessary stress on your system. And you could probably get much better results than a typical passive system. And some of the conversation that we've had over the past couple of days about this is, if you're weighing the option of going with an amplifier and a pair of speakers with a passive network, you might want to look to see what it would cost to do an active system and maybe not spend as much on speakers. Believe it or not, I am saying that. You can get a less expensive set of speakers to sound better using an active system than using the typical passive that will come with them. Think about that for a second. So the whole cost benefit here, you don't have to spend as much money on speakers and still be able to get really good performance, especially if it's a DSP. If you've got a DSP, you'll have equalization and a whole bunch of other things that you can adjust. So the reason to do passive is simply out of just raw convenience and really sensitive price points, really sensitive. So like I'd sooner do an active system at C2 or C3 than try to jump up to a C5 if we had them or a C7 product and try to force it to use some kind of passive network. It's just not worth it. But the cons on passive are huge compared to the one possible con on active. In other words, as everyone in the chat was saying earlier, DSP for the win, active for the win. Absolutely, 100%, without any hesitation. If you can go active, you should, period.
Yeah, I mean, going to what you said, Steve, I know Glenn Savage, is a great dealer of ours. His number one selling setup is VXI with C2 speakers, so he can hit the price points the customers need. If they want to spend more or they want more, then they pay for the more expensive speakers. But, I always felt, when we first started getting into DSP at JL Audio was right when I first started. We were developing the tweak. And I remember traveling with Steve, and we went to install bays on our travels, and we would talk to installers and kind of pick their brains. How do you use DSP? We were getting info so we could, work on our software. And I always noticed it almost was as if a lot of the time DSP was put on the top shelf. It was for like C7 type customers only. And, it shouldn't be that way because you can make an entry level pair of speakers sound phenomenal. And, to me, I'd rather go active with lower quality speakers because I'm going to get so much more out of it at the end of the day than I would paying for something premium that's not truly being optimized and restricted by a passive network. I mean, let's say C5 and C2, they have similar characteristics. C5 naturally are going to be a little more refined, but passive C5s compared to active C2s where we can really, with delay and levels, get a true stereo image that you just can't do with a pair of passives, that alone is going to make the experience better. And then we can take care of the acoustical issues in the car, the spikes, the nulls, any time-related issues, and really, truly make a next-level system that can be extremely affordable because you don't have to have those top-notch speakers. Of course, we would love for everyone to buy but realistically, it's not possible, you know?
Right.
So don't look at having to always have the best speakers. Be okay with something a step or two down, and know you're going to get way more performance out of them with that DSP than going with something more expensive and that really restricting passive network. And I remember when we came out with C7s, I was listening to Dwayne. He's our VP of speaker engineering, and he was being interviewed by Mobile Electronics Magazine, and they asked him, you know, why are C7s, why no passive crossovers? Why are you requiring an active crossover network? And what Dwayne said really stuck with me. He's like, when you think about high-end precision speakers like a C7, using a passive network, even with the best coils and caps and resistors, there's still losses, there's still compromise. And it's like putting a veil over the speaker. And why would you do that? Why would you purposely degrade your speaker's performance? And
it's an excellent analogy, the veil in front of the speakers. Yep.
Yeah.
Yeah.
So, you know,
anything between your amplifier and the speaker has a chance to degrade that performance 100%.
Yep, absolutely.
Even the highest quality. And one of the best crossovers that our company's ever done was in that ZR or ZR for the guys everywhere but here. So the ZR crossovers, those are really, really good passive networks. You know, we put in some of the best components we could to try to minimize those losses. And even as good as they were, it's not enough for a C7.
And you think about it, when you go to a three-way passive network, it becomes even more critical, because now you have levels of 3 different speakers. You have crossover points of 3 different speakers on there, and it becomes a lot more critical. And honestly, if you're doing a 3-way, I active is the absolute only way.
It's the passive parts, the components alone for those lower frequencies, they become hideous. The physical size of them to prevent the losses, that doesn't make sense. Just go active, man, all day. It actually may be cheaper to go active when you start getting into a 3 or 4-way system.
Right.
Because the parts to do it correctly passive, it's just, first of all, you can't find them anymore. Second of all, they'd be really, really expensive. Active. Let's go active.
So we're going to get into real quick active versus passive, and we're going to talk a little bit about the tuning aspects of this and kind of some of the differences that you're going to look at. I tried to pick 2 really equally priced systems here. So we have some C3 components. We're running them active off of the EXI, and then we have them also on the right-hand side there running passive off of an HD amplifier. So again, price points aren't really going to be a big deal in a competition between these two, because your price points are going to be right about the same on there. So we're going to go through and we're going to utilize those 2 as examples on there, and go through and talk about one of the main things that we talk about, or one of the main standards that we talk about for good audio, is imaging. And to get proper imaging, we kind of need to have the 3 pillars on there to get that set up. And those are kind of the building blocks in there. And when we talk about these 3 pillars, the first pillar is your channels must have the same level or the same gain. So everything must be the same level at the listening position. I will clarify that, and that is an extremely important clarification, because just because you're playing all of the speakers at the same level doesn't mean that at the listening position they are going to arrive at the same level, because you have different distances and all of that stuff. So we need to make sure that they have all of the same level at the listening position on there. The frequency response must be the same at the listening position. Again, that's the clarification in there. And the phase, or the timing of the response of the channels, must all be the same when they get to that listening position on there also. And those building blocks all come together to build up a good, solid image in the vehicle. So when we talk about the differences between active and passive, and how we can go ahead and manage these 3 pillars, let's start off with pillar 1. And if each speaker's run off of a designated channel in an active setup, then we can actually use the level adjustments to equal each side out at that listening position, especially if it's DSP and we have separate channel adjustments on there and all of that good stuff. So when we're running that active system, we're able to go ahead and designate each one of those channels and take the level of the tweeter that's really close to us and bring it down a little bit more, or take the mid-bass driver that's close to us and bring it down a little bit. So that way, when we are at that listening position, we're very, very equal in there. Now, if we're trying to do this on a passive network, and you guys mounted that passive network in the door and the door's all buttoned up, are you going to open that door up and take that jumper from negative 2 dB to negative 6 dB if you need to go ahead and do that? Most of the time, all that we're doing with those is turning the tweeters down to where we want them to and just leaving that level at that point in there. So we need to make sure that that we are getting that tuning and done properly. And with active system, very, very simple, very easy. Getting in that passive network, it becomes much, much more difficult to get your level settings all straightened out because you are on your outputs on there. They have to use the jumpers inside the passive network and all of that good stuff. So you'll be able to get them fairly close to one another. And if you do your attenuation, then you're going to be attenuating from the amplifier, you're going to be attenuating that entire passive network all in one whole, not individual speakers. You can get them fairly close, but it is going to take quite some time to be able to go through and do that. Now, pillar 2, when we're using an active setup, again, we have the ability to adjust our high-pass filters and our low-pass filters separately to make those speakers really work well with one another in that given environment. And like we said, a mid-bass driver and a well-deadened door is going to react a lot differently than one that might be in like a Jeep JL that's at the bottom of the dash right by your knees there. So being able to go through and change those filters up and change that high pass and low pass at those crossover frequencies, we're able to really help dial those in. In a passive network, we could probably use some EQing to make some adjustments at there, but it's really not the best way to do it. So again, your active speakers are really going to help you out there. And also, if you're using active off of each separate channel, you're going to end up having more EQ capabilities to be able to run more adjustments to be able to go through and do that rather than having to use your high pass, or you're able to use your high pass and low pass filters rather than having to use EQ adjustments. A lot of times you'll see dips or rises at your filter points. Maybe you have too much energy at the filter point or not enough energy at the filter point. Well, instead of using an EQ, we can actually change those filter points and bring them together to take care of that dip or widen them out a little bit if there is a peak there. So we're able to use those EQs. If you're using a passive network, you cannot go ahead and do that. Finally, the last one is phase. So you have your delay or your all pass filters in there, and phase is measurement of time, and having the system running all active will really allow us to dial our system in here. If you have a passive network, you'll delay to the mid since it produces the most energy more often than not, I should say. And your tweeters will just kind of be there along for the ride and not have the same timing or the correct timing that they should arrive in that listening position on there. Also, if you're running active, you can get into things like measuring them differently rather than just taking a tape measure and doing all of that. If you have individual drivers on channels, maybe you can take impulse responses of the driver and all of that. Things that you cannot do if you have a passive network in line that is going to join that tweeter and mid-bass driver together. So the other thing is that when you are tuning and you are using a measurement system, you want to go ahead and tune to a curve. These are a few curves, preset curves that we are just showing here. We're not saying to use any specific ones or anything like that. Just showing you what you want to kind of utilize one of these at some point in time and take measurements so that way they are consistent, I should say, is where I'm trying to go with
Just
here.
a quick point on these curves. They are offset so you could see each one of them. Otherwise,
Yes.
a lot of it would be overlapped. But you'll see that throughout that middle area. On the left, you'll see the subwoofers, and you'll see the pink and the blue one are similar, and the green and the brown one are similar. So there's differences simply in level and the taper off on the low end. the next section over, they're very, very similar to each other in terms of their transition shape. There are some subtle differences. And as you go through the next section, again, due to the offset, they look that they're very different, but they're really not. The true differences will show up on the far right. The blue one and the green one are very similar, and the pink one and the brown one are very similar. And what Kevin's referring to in terms of tunability, the level adjustment that you have in each one of these 4 sections that are represented here in an active system is very flexible. In a passive system, far less so.
Yeah, and meeting your target curve, it can be accomplished realistically with either passive or an active system. It may be a lot more difficult. You might not be able to get as close with a passive system. You just have a lot more tools in the toolbox when you're going active to be able to really get to one of these curves. And depending on how the system is presenting itself would kind of depend on which curve you would want to pick with one of these. So you want to kind of stick close to where your system is presenting itself. You're going to be a lot faster. You're going to get to where you need to go a lot easier when you are in an active system on there. And this is just breaking it down. So we have our curve that we are tuning to, and this is just showing you the yellow is a target sum, and all of the different pass bands for the various drivers, including the subwoofer, just working together to give us that final sum target value and to get that driver alignment and levels, frequencies, and time is nearly, if not impossible, to do properly with passive networks. Utilizing an active network will allow you to get each one of these individual drivers aligned to where it should be and be a pleasing listening experience when we hit that summed target response on there. So wrapping things up here, active versus passive. Active really is the clear choice. If you couldn't tell by the entire presentation that we've gone through here, more control, more efficient, better fidelity. You have less guesswork of what your settings are and what you're doing in the system. It's easier to install. You don't have these passive networks to go through and mount and do all of that stuff. And it is a faster setup when you're doing it properly. Being able to make a level adjustment in DSP is a lot easier than finding where this is underneath the carpet or inside the door and pulling the jumper and doing all of that stuff. So it is a much faster setup time when you are doing that properly. So which one is right for you? Well, are you looking for the most performance out of your system? Are you looking for the best reproduction of the music that you're on there and getting the most efficiency out of your system? Do you want more flexibility to be able to go in and do some tuning on there? Or are you looking for something that's a little bit more simplistic? And does your budget allow for that active system on there too? And we would all contend to say, again, if you don't have the budget to buy the highest end speakers, maybe cut back on those speakers a little bit and put a little bit more into the amplifier that you're purchasing. You're probably going to get a better experience by doing so. And if you have any questions on how to set up an active system or need help with the design of your system, please feel free to contact our tech support.
I thought you were going to give him Steve's cell phone.
No. You know what's bad about that? If you call me on my cell phone, I have no way of texting the tech guys to come and help you because I'll be on my phone.
But if you need help in setting this up or doing any of that stuff, please contact our tech support. They're there to help you. Again, best guys in the business, very, very knowledgeable. They enjoy doing a lot of this cool, integral stuff, especially with the system design aspect and all of that good stuff too. So the help icon on the support link on jlaudio.com is the best way to reach them. If you're not available or if you don't have that capabilities, you can email them at technical@jlaudio.com, or you can call in and follow the prompts. But again, the help icon is the easiest way and the best way to get them. Now, if you don't need tech support and you want to talk to us about something other than tech, like maybe, hey, Tuesdays work better for me, or hey, I'd like to hear more about this type of content, feel free to email us. What
does Rob like, you know?
Yeah. What's Rob's beer of the week this week or anything like that? Feel free to contact us at training@jlaudio.com. so that way we can get your request taken care of. And Rob will see that email, so he can let you know which beer he is preferring this week or month or what have you there.
Awesome.
So I'm going to hop out, and
there we are.
Yeah, so
we good?
Oh, go on.
No, go ahead.
I was going to say we answered most of the questions in the chat, but there were a couple I wanted to bring up real quick here, just for clarifications. First one was from Kenneth Wright saying, wait, there's delay compensation on your crossovers. So just in case you weren't there for the beginning of the session, one of the benefits of going active is you now have, the way I look at it, speaker-specific signal going to every speaker in the car. And that means we can now apply delay to individual speakers when we go active.
With a DSP.
With a DSP, yes, going active with DSP. That allows us to do that. When you go passive, you're restricted because if you think about it, let's say you set your amplifier at 80 hertz high pass. We now have 80 to 20,000 hertz going to our passive crossover, which then splits it to the individual speakers. But we don't have control over what's leaving the crossover to each of those speakers. So if we add a delay, we're delaying everything. We can't delay, say, the tweeter to the mid-range so they arrive at the same time. So by going active with a DSP, you now have speaker-specific signals that you can then manipulate, and one of those, corrections, however you want to say it, is signal delay. So it's not the crossover itself, but by having that specific signal, delay is one of the key components that will help make the system sound better.
Right, but it's not always there. Like an analog active filter may not have an adjustment for phase or any of the time compensation. That would be a function of typically a DSP. There are other ways of doing it, but it's almost always going to be with a DSP. There were a whole bunch of comments regarding like specifics on system tuning and appropriate level settings and things of that nature. Slightly outside the scope of today's conversation, but definitely a topic that we're very, very focused on. And we have done some classes on that. And I'm looking into a crystal ball, and I see further classes in our near future on exactly those topics. So I know Paul and Josh were having a really good dialogue about how to set up a system, what tools you need, and things of that nature. I wouldn't go out and buy anything just yet, because there may be tools you either already have access to, or maybe you don't need the tool you think you need. But again, you can contact us offline for some of those details, and we'll be happy to help. There was a comment that I just wanted to touch on quickly. I got to get back to the full chat there. Someone was asking about Q. Q is kind of an interesting term. It shows up a lot in audio, and it can be very, very confusing because it sort of changes its context a little bit depending on what you're talking about. But it has a lot to do with the shape and things of that nature for a given filter. A lot of DSPs, including ours, they don't really have a dedicated control for the Q of a high pass or low pass filter. It's not unheard of, though, especially with some of the other products that we have. As a company, JL Audio manufactures a product called the CR1 that has a damping control on it, not a dampening. Dampening is what happens when you throw a product in a pool. Damping is referring to the response of the filter itself, and it is a Q adjustment at heart, really. So I forget who that was asking about that. But yes, in some cases you can adjust the Q of a filter, although it's not as common as you might think. And it usually is set up for something that's dedicated for a specific application, like a subwoofer crossover in the CR1. So take a look at that if you're interested in things of that nature.
Good question that just came in from Paul, and we can probably briefly cover this real quick, but he doesn't understand the dB settings in crossovers. So I think he's probably talking about the slopes. Do you want to talk about that again real quick, Kevin, since it's fresh on your brain?
Is he talking about the slopes, or is he talking about like the dB control on like a passive network?
Good question. Let's talk about both real quick.
So your dB level, you have reference, you have a -2 and a -4, and these are just the levels of how the tweeter is going to present itself. Is it going to be a little bit louder or a little bit quieter, depending on where you have this setting at on there? And unfortunately, let me move it back some so maybe you can see the
That's
the
good.
wording on there is not coming through. It's a little blurry, but depending on where you put this jumper at, there's a little jumper that comes with it. And depending on where you put this jumper, the reference means that the tweeter is going to present itself at kind of a flat deal. And then if you go -2, that's going to bring the tweeter attenuation down a little bit more. And then if you go -4, that's going to attenuate it a little bit more. If you go up to +2, then that's going to brighten your tweeter up and give you a little bit more output on there.
Like a stationary volume adjustment.
Something like that, yeah.
Like that.
It's specific just for the tweeter at that point. So if the tweeters are bright, you might want to knock them down. If they're not bright enough, you put it back to the reference. There are some passive networks that I've seen, including some from us, that had a positive value. And it seems odd that you'd be able to gain through the network, and truly you're not. It's just we're reducing the amount of attenuation. And again, one of the strengths of an active system is you have full control over all of that. So that's what that aspect of DB would be on a passive network. It would be a level control. But probably the more common one would be the rate or the slope. So X number of dB per octave is usually what people will see, 12 or 24 dB per octave, 48 dB per octave. And that's an indication of how rapidly that filter is going to get rid of the frequencies above or below that point if it's a high or a low pass filter. The most common one, as was mentioned by Kevin earlier, is a 24 dB per octave filter. Seems to be the standard go-to by almost everybody, almost all the time as a starting point. But ultimately, at the end of it all, especially with an active filter, the right filter is going to be the one that gives you the best performance and reliability when you're done tuning the system. Good starting points: 80 hertz high pass, low pass, 24 dB per octave between your subs and your main speakers. If you have other filters that you can control above that, 5K for tweeters as a low pass for your mid-range drivers is a common point. Again, 24 dB per octave. And then if you're dividing the mid-range and mid-bass into two separate drivers, usually 500 hertz is a good high pass, low pass point to start with. Check with your manufacturer of the products that you're using for more specific information, or if you're using an active, get a measurement system and start measuring it for yourself and learn. There's lots to do there. So, excellent question, and I appreciate that Paul asked it. So,
yeah, a lot of times when when we're looking at an active system, we'll measure it without a filter on it just to see how the speaker kind of reacts and presents itself to the vehicle. Not with tweeters, but
so what I do on tweeters when I'm doing an active system, before I actually determine what my ultimate high pass frequency would be, I put a filter at a point lower than I would normally do, but safe enough that if I'm listening to it at a moderate level with pink noise, just so I can get an idea of what that measurement's going to look like. So let's just say I'm anticipating it's going to be 5,000 hertz high pass or whatever the case may be. I may go as low as 2,000 or 1,500. Listen to it with pink noise and kind of take a measurement using an RTA or something with a microphone and look at the measurement and see how that roll-off is occurring naturally. Most tweeters are going to have a roll-off before the high-pass filter that I've set as a precaution. 1,500 hertz on a tweeter that's intended for 5,000 for a short period of time is not going to be damaging. 50 hertz into a tweeter could be potentially damaging. So I want to get away from those frequencies while I'm doing my initial measurement for tuning purposes. So. What else we got there, boys?
I think that's about it. Jeffrey was saying he uses 24 dB Linkwitz Riley in his car. I think he just won a couple trophies at a competition a week or two ago, so more than just a starting point for him.
It's true, yes. I wouldn't be surprised if Jeffrey's tale is common amongst many of us, that we pick that as a starting point and we wind up at an ending point. Now, the frequency may be different than our original starting point, but it would be uncommon to make drastic changes in your slopes between your different drivers. One of the things that Kevin talked about with the tuning process is that in addition to level and magnitude or frequency response, but the phase alignment of the various drivers needs to be in line. And maintaining your filter slopes to be consistent can really help in that regard, which is probably why Jeffrey's been successful in the competition lane, is he's probably already figured all of that out. Whether he did it by measurement or he did it by listening, I'm sure he's already figured that out. And
he measured first and then did a lot of listening after. Right?
And that's the best thing to do. I mean, any tuning process, wherever you guys are, whatever process you guys are following, There is going to be a method, or should be a method, to get to a point where you can then start listening. So even the best measurement systems in the world, when you get to a certain point, there's only so much the measurement can tell you. You have to listen and see how the system presents. The goal of a good measurement system is get you there faster so you can spend more time listening. And ultimately, that's what I want to do. I want to listen to the system, and I want to make adjustments on the fly. And when you do that, just for the record, we're jumping into a lot of the tuning stuff now. But when you are tuning the system, I would not make gigantic changes in filter frequencies. The measurement's going to get you really good in that regard. And it's going to protect your drivers as well. So making a gigantic change there does run the risk of causing some possible problems in the tuning process. I just got to jump on Josh Collins for a second. He says, you remember some of the builds back in the day that had a really massive passive networks? Yeah, I remember those systems as well because I'm old. But I remember one of the systems, and I'm sure somewhere around here we can find images of, it was a red blazer that the team from Speaker Warehouse put together with some guidance from some critical people at JL Audio. And it had a low pass filter on 4 10W5s, I think is what they were. I can't remember. It's a long time ago. And the passive network was a gigantic, without exaggeration, it was like the size of my arm, coil, and big iron things in the middle wrapped in tons and tons of wire. And you just look at it, it's like, wow, why do you need that? It's because it's a low pass filter, passive on the output of an amplifier. And if you used anything with smaller wire, the resistance skyrockets and you wind up with no power. So you need a really thick wire, and now thick wire, all kinds of problems with it. Can it be done? Yeah. And Josh remembers it. I remember too. But even with that knowledge of what the guys at JL Audio and Speaker Warehouse did back in the day, now active always, always. Anyway,
I think that's about it.
I think so too. This was great. So the chatter in the chat was really, really good today, Kevin. I know you couldn't see it real time, but you scroll through it a little bit later.
I'm scrolling through it now.
Yeah. So, thank you everyone for tuning in. As Kevin mentioned, reach out to the training guys if you're interested in a specific topic. If you prefer a different day or time, we could take that into consideration. These Thursday afternoon sessions for Kevin and I work out really, really well. Not just for Kevin and I, meaning afternoons for Kevin and I. It's early afternoon for Rob. These work out really well for us, and we seem to get some good attendance. If you guys want to see something different, let us know. But until next time, I'm going to say good night and farewell, and we'll see you soon.
Thanks, everyone.
Have a good night, everybody.